After studying this module, you will be able to know about various preliminary tests for drug identification, the significance of preliminary examination like the color test, crystal tests, etc., and the limitations of preliminary screening and approaches to overcome them. Preliminary screening of drugs are basically done by color test, also sometimes referred to as the chemical spot tests, provide with one of the leading tools for the presumptive identification of drugs. These color tests are most practically applied to pharmaceuticals and scene of crime residues, and to a lesser extent to biological fluids such as stomach contents, urine, etc. They are used to place the unidentified into a specific class of compounds or to eliminate categories or classes of compounds. These color tests remain popular for several reasons. They are simple to perform and no extensive training is required. As such, they appeal in situations where laboratory facilities may be very limited. They can be performed in the field by police officers or technicians, require minimal reagents, and are inexpensive and give immediate results that can be viewed by the bare eye. In many instances, color test can also be used as thin layer chromatographic location reagents applied by spraying or dipping. Color test can provide an indication of compound class for more rapidly than immunoassays and chromatographic techniques such as the gas chromatography and high performance liquid chromatography or the HPLC. Color tests are only an indication of the presence of a compound or class of compounds, and that all tests must be confirmed by more specific methods. This is exclusively significant where test results may ultimately result in protective sentences. Tests are usually carried out either in a clear glass test tube or on white glazed porcelain tiles or the spotting tiles, which give a uniform background against which colors can be viewed or assessed. A sample known not to contain the compound of interest should be tested at the same time as the test sample. This enables a comparison of the colors produced by the sample and by the reagent blank. It is essential to validate all tests and test reagents for sensitivity and specificity. Forensic significance of drug identification. Use of drugs is not a menace anymore. It has become a rampant. Most cases that arrive in a forensic laboratory start with the suspicion that a drug is present. A fatality might be an accident, suicide, or murder, but a toxicological examination must be carried out to assist the investigating officer to decide which of these it might be. Often the investigating officer will not know whether or not any offense has been committed until the results of the toxicological analysis are available, so that formulating the correct questions for him or her to ask is vital if accurate and useful answers are to be given. It should be remembered that basic tests are not in any circumstance intended to replace the pharmacopoeial requirements, but should be used as a rapid and inexpensive means or method to substantiate identity and the strength of drugs and medicinal products, and possibly to detect poor quality counterfeit and other substandard products. In the event that suspect products are detected, these should be tested for compliance against pharmacopoeial requirements. Now we will study about some of the widely used color tests. First is the Shen-Kao reagent test. Preparation of reagent. For preparation of reagent, reagent 1 will have 1 ml of glacial acetic acid in 100 ml of water, that is 1% volume by volume aqueous acetic acid solution. For reagent 2, this is prepared by dissolving 1 gram of copper sulfate in 100 ml of water, that is 1% weight by volume aqueous copper sulfate solution. For the preparation of reagent 3, dissolve 8 grams of sodium hydroxide in 100 ml of water, that is 2 normal aqueous sodium hydroxide solution. This test is used to distinguish ephedrine, pseudoephedrine, norepinephrine and meth cation from amphetamine and methamphetamine. The latter two do not react with Shen-Kao reagent. The reagent is prepared in 3 parts. In this table we have shown in the first column the compounds, and in the second column we have shown the results obtained from the Shen-Kao reagent. For ephedrine, the color obtained is violet. For pseudoephedrine, violet color. For norepinephrine, bright blue precipitate. Nor-pseudoephedrine, blue precipitate. In case of chlor-pseudoephedrine, bright blue precipitate is obtained. N-methylephedrine, pale blue precipitate. Cation, pale blue precipitate. Mid-cation, bright blue precipitate. Next is the cobalt thiocyanate test. This test is a presumptive field test for illegal drugs. The test reagent is a 2% aqueous solution of cobalt thiocyanate, which is mixed with a small amount of sample. A brilliant green-blue color is produced by the hydrochloride salts of benzophenamine, chlor dioxide, chlorpromazine, methadone, methylphenidate and brompheniramine, malate as well as the hydrocodone tartrate. A strong but less green-blue color is produced by the hydrochloride salts of cocaine, diacetylmorphine or heroin, ephedrine, mepridine, phencyclidine, procaine, propoxyphene and pseudoephedrine. Alkaloids present in drugs and other materials are also indicated by the application of this test. Next is the Dile-Kopiani test. Preparation of reagent. For part A, this is prepared by dissolving 0.1 gram of cobalt acetate dihydrate in 100 ml of methanol and subsequently mixed with 0.2 ml of glacial acetic acid. For part B, this is a 5% isopropylamine volume by volume in methanol. Dile-Kopiani test reagent is used as a simple spot test to presumptively identify barbiturates. 2 drops of part A are dropped onto the suspected sample or substance, followed by addition of 1 drop of part B, and any change in color is observed. The test turns positive for phenobarbital, pentobarbital, amobarbital and secobarbital, light purple by appearance of cobalt with the barbiturate nitrogens. Then next comes the Dragendorf's reagent test. For preparation of reagent, take 1 gram of bismuth subnitrate dissolved in 3 ml of 10 molar hydrochloric acid. It is diluted to 20 milliliter. 1 gram of potassium iodide is dissolved in it. If black precipitate of bismuth triiodide separates, it is dissolved in 2 molar hydrochloric acid. Now this table shows in the first column the color, and in the second column we have the compounds for which they are valid. So in color, if it is red to orange or brown to orange precipitate, it means the compounds present are secondary or primary or tertiary amine. For orange spots, the compounds present may be alkaloids and benzodiazepines. For yellow orange, red orange or brown orange spot, amphetamine. For orange or red orange or brown orange, it is active constituents of papaver somniferum. Next comes the Diaconus-Levine test. The Diaconus-Levine test reagent was originally developed in the 1930s by Pierre Diaconus. The reagent is prepared by 5 drops of acetaldehyde and 0.4 grams of vanillin, further dissolved in 20 milliliters of 95% ethanol. This test is recommended for the identification of cannabis. When a small amount of suspected residue of the extract is placed in a test tube and shaken with 2 milliliter of Diaconus reagent for 1 minute, and further 2 milliliter of concentrated hydrochloric acid is added, shaken and allowed to stand for 10 minutes. If a color develops, 2 milliliter of chloroform is added. The violet colored lower chloroform layer gives the positive indication of the presence of cannabis. Next is the Frod's reagent test. For preparation of reagent, 50 mg of molybdic acid or sodium molybdate is dissolved in 10 ml of hot concentrated sulfuric acid. The resulting solution should be colorless. Appropriate amount of the suspected material or exhibit is taken on a spot plate and added to it the few drops of Frod's reagent. The appearance of brown color indicates the presence of mescaline. The conversion of brown color to purple indicates the presence of methylene dioxyamphetamine or MDA. Amphetamine gives brown yellow color, whereas presence of opium alkaloids is indicated by violet color changing to green and finally blue. In case of ergot alkaloids, a color change from deep green to red, grey and finally blue is observed. Next comes the Forest reagent test. For preparation of reagent, equal volumes of 0.2% solution of potassium dichromate is taken, 30% volume by volume solution of sulfuric acid and 20% solution of perchloric acid and a 50% solution of nitric acid are mixed. Phenothiazepines gives red, violet red or brown red, orange, pink orange, red orange or brown, whereas imipramine and related compounds give blue color. Next comes the Fisher-Morris test. For preparation of reagent, in reagent A we have concentrated formic acid, and in case of reagent B we have 5% aqueous sodium nitrite solution. 5 drops of reagent A and 3 drops of reagent B are added to the sample. After 2 minutes, 15 drops of chloroform are added and color of layers are observed. Heroin, diphene, hydramine, diazepam can be detected by this Fisher-Morris test. Next is the Marquis test. For preparation of reagent, we have 1 volume of formalin added with 9 volumes of concentrated sulfuric acid. Yellow to orange color will be the presence for benzodiazepines, brown orange for amphetamine, purple red color is produced which changes to violet and finally blue is for the opium alkaloids and brown for the ergot alkaloids. Next comes the Mandelin test. For preparation of reagent, we have 1% solution of ammonium vanadate is added to concentrated sulfuric acid. This test is performed for the detection of ergot alkaloids. To a portion of the dried residue of the extract, 1 drop of reagent is added. A purple-brown color develops indicating the presence of ergot alkaloids. In case of Van Eyck reagent test. Preparation of reagent. 1 gram of para-aminobenzaldehyde is dissolved in 100 ml of ethanol and adding of 10 ml of hydrochloric acid. To the dried residue of the extract, 1 drop of Van Eyck reagent is added. A green color changing to blue is observed. Next comes the Husemann test. To a little dried extract in a porcelain basin, 2 to 3 drops of concentrated sulfuric acid is added and heated on a water bath for 30 minutes over a small flame for a few minutes until white fumes appear. A reddish or reddish brown or black color appears. It is cooled. 1 drop of concentrated nitric acid and a crystal of potassium nitrate are added. A reddish violet color appears, which immediately changes to blood red and then to reddish yellow and finally fades away, indicating the presence of opium alkaloids. Next is Zwicker's test. The residue of extract is taken up in chloroform. To 1 ml of chloroform, extract 2 to 3 drops of 0.5 ml of 5% pyridine in chloroform is added and shaken. The color of chloroform layer becomes purple. Then 1 drop of glacial acetic acid is added. If the color of the chloroform layer changes from purple to weak blue, the presence of non-thiobarbiturates is indicated. If chloroform layer becomes green after adding of pyridine in chloroform, the presence of thiobarbiturates is indicated. This green color changes to light green on adding acetic acid. Next comes the MEX test. The MEX reagent is used as a simple spot test to presumptively identify alkaloids as well as the other compounds. It is composed of a mixture of selenious acid and concentrated sulfuric acid, which is dripped onto the substance being tested. Next is the Simon's reagent test. Simon's reagent is sodium nitroprusside in a basic buffer. It works by detecting the secondary amines such as the meth and methamphetamine and methylene dioxymethamphetamine, that is MDMA. If a substance tests positive for an ecstasy-like substance by turning to purple or black with Marquis or MEC or to blue-black with Mandelin, then a color change reaction with Simon's indicate the presence of MDMA or MDE. Next comes the Mayer's reagent test. Preparation of reagent: potassium mercury iodide prepared by dissolving 1.357 grams of mercury chloride and 5 grams of potassium iodide in 100 ml of water. This test is performed for the detection of nicotine. The dried residue of the extract is acidified with acetic acid followed by addition of 2 drops of reagent. A white or yellowish precipitate is obtained. Next comes the FPN test. For preparation of reagent, we have 5 ml of ferric chloride solution, 45 ml of 20% weight by volume solution of perchloric acid and 50 ml of 50% volume by volume solution of nitric acid is added to make a final solution. Phenothiazepines give orange red or violet red or brown red or orange or red orange or pink orange or blue, violet or red brown color. Next is the McNally test. To the residue of extract of biological materials, a few drops of acetone and 1 to 2 ml of water are added. 2 drops of 0.5% copper sulfate solution and 10% acetic acid is added, followed by a pinch of solid sodium nitrate. It is shaken and heated gradually to boiling and maintained in boiling condition in a few minutes. A red color is formed if salicylates and salicylic acid are present. Next is the urotropin test. This test is performed to identify the alkaloids. To a little dried extract in a porcelain basin, a few drops of aqueous solution of urotropin is added and warmed slightly. A purple color changing to blue and then to green is observed. Next is the Scott's test. For preparation of reagent, we have reagent that is prepared by dissolving 2 grams of cobalt thiocyanate in water and diluted with 96% glycerine in water in the ratio 1:1. The residue of the extract is taken in a test tube and the reagent is added. The mixture is shaken and a blue color develops at once, which indicates the presence of cocaine. Methaquilone also gives a positive reaction. If a blue color develops, 1 drop of concentrated hydrochloric acid is added. The blue color disappears and a clear pink color appears. If a blue color does not disappear, 1 drop of concentrated hydrochloric acid is added, then a few drops of chloroform is added and shaken. The chloroform layer becomes intense blue. Next is the fast blue B test. A small amount of residue of the extract is placed in a test tube and a very small amount of solid fast blue B reagent, that is solid fast blue B, anhydrous sodium sulfate in 2.5:100 ratios added. 1 ml of chloroform is then added and shaken. It is kept for 2 minutes. The chloroform layer becomes purple red in color, indicating the presence of cannabis. Next is the Gerrard's test. 1 to 2 ml of 2% mercury chloride solution in 50% of alcohol is added to a portion of residue of the extract. A red color develops immediately. Hyoscyamine produces a yellow color which becomes red on burning, while hyoscine does not produce any change of color. Next is the Vitali's test. A portion of residue of the extract is treated with a few drops of fuming nitric acid in a porcelain basin. It is evaporated to dryness on a water bath. The residue is cooled and moistened with a few drops of freshly prepared alcoholic caustic potash solution when a violet color is produced, which soon changes to red and finally disappears. The color may be made to reappear by adding more alcoholic caustic potash solution. This test is performed for the detection of atropine, datura, and ergot alkaloids. Here we have the summarized test indications. On one column we have shown the substance or their functional groups, and in the second column we have shown the useful tests or reagents. For alcohols it is potassium dichromate. For alkaloids and nitrogenous bases it is Dragendorf's reagent. For amides, aliphatic in nature, it is Nessler's reagent. For amphetamines it is Marquis Test, McNally Test, Fraud's reagent and Mandelin's test, sodium nitroprusside and acetone. For antidepressants, Marquis Test. For barbiturates, Dile-Copiani reagent or Copiani-Zuiker reagent, mercurous nitrate, vanillin reagent and the Zuiker reagent. For benzodiazepines, formaldehyde, sulfuric acid. In case of cannabis, it is Diaconise reagent that is used. For carbamates, that is non-aromatic, furfural-dehyde. Next is cocaine, that is cobalt thiocyanate test or the para-dimethylaminobenzylaldehyde or Mandelin's test or Scott test. For chlorinated phenols, it is nitric acid, fuming nitric acid. Next is chlorinated hydrocarbon insecticides, nitric sulfuric acid test. For cyanide, it is ferrous sulfate, sodium picrate. In case of cyanide groups, sodium picrate is employed. For dithiocarbamates, sodium nitroprusside, ergot alkaloids, para-dimethylaminobenzylaldehyde. For halogenated hydrocarbons, Fujiwara test is employed. For amides, it is Copiani-Zuiker test. In case of ketones, it is sodium nitroprusside. For methadone, tetrabromophenolalphthalein, ethyl ester, cobalt thiocyanate. or Mandelin's test or Marquis test. For monosubstituted pyridine ring, it is cyanogen bromide. For nitrates and nitrites, it is ferrous sulfate. In case of opiates, it is Marquis, MEC, Frod's and Mandelin tests are carried out. In case of oxidizing agents, diphenylamine is used. For phencyclidine, it is tetrabromophenolphthalein ethyl ester. In case of phenols, ferric chloride, Folin CO-calcium reagent, Millin's reagent, para-dimethylaminobenzaldehyde are employed. In case of phenothiazines, formaldehyde sulfuric acid, Forest reagent, FPN reagent and ferric chloride are used. In case of phenyl pyroxolenes, nitrous acid is used. Primary aromatic amines, diazotization, coniferyl alcohol is employed. In case of primary and secondary amines, Simon's test or Dragendorf's reagent is used. In case of propoxyphene, cobalt thiocyanate, Frod's reagent, Lieberman's test, tetrabromophenolphthalein ethyl ester. In case of quaternary ammonium compounds, tetrabromophenolphthalein ethyl ester is used. Next comes the quaternary amines. Dragendorf's reagent is used. In case of quinines, phthalocyanine, cobalt thiocyanate is used. For salicylates, it is ferric chloride, Trender's reagent. Next is the steroids, antimony pentachloride, naphthol sulfuric acid and sulfuric acid are used. In case of sulforamines, copper sulfate, Copayanis-Zucker reagent and mercurous nitrate or nitrous acid are used. For sulfur-containing compounds, palladium chloride, sodium nitroprusside is used. And in case of tertiary amines, Dragendorf's reagent, tetrabromophenolphthalein ethyl ester is used. Now we will study about the limitations of color test. Colors exhibited by these tests cannot be described with any accuracy. They may vary in intensity or tint with the concentration of compounds in the test samples and the presence of extraneous material. In addition, their assessment is always a subjective one, even in people with normal color vision. For example, the Marquis test is stated to give a black or blue-black color with MDMA and a green-black with lysergide. Even in the pure form, these colors may not be readily distinguishable. Add to this fact that most drugs of abuse are more routinely encountered diluted with a variety of other substances, and one can begin to appreciate the difficulties that can arise in the real world with color test. Some of the complexes formed are unstable, so that the color changes or fades with time. Salts may give different shades of color or different colors from those of the corresponding acid or base. In general, the free acids or bases that have been isolated from the test material by an extraction process give better colors than their salts. The color of salt may be modified by the nature of the other ions present. Now we'll summarize all that we have studied in this module. The color test provides a relatively rapid and inexpensive indication of the presence of absence of a substance and an indication of the identity of a substance. The emphasis for color test is an indication. Such tests do not produce confirmation of identity. The color tests provide toxicologists and drug analysts with one of the first tools for the presumptive identification of drugs and poisons. They are used to place the unknown into a specific class of compounds or to eliminate the categories or classes of compounds. Color tests are particularly important in clinical toxicology, especially where a patient is being treated in accident and emergency and clinical symptoms may indicate some form of poisoning. Color test can provide an indication of a compound class far more rapidly than the immunoassays and the chromatographic techniques such as the GC and HPLC. Color tests are widely used by the police authorities and customs to detect the drugs of abuse. And lastly, the color tests range from those that rely on reactions with certain functional groups to those that are almost specific for a given group.